Hey everyone, I'm Matt. I am DevRel at EigenLayer. My original talk didn't make a lot of sense, I think, and it was called EigenLayer Scaling Verifiability. So I wanted to make it a little bit more practical. So it's what's going on at EigenLayer. All right, so rough agenda and the intention for this is I think that there's a lot going on in the EigenLayer ecosystem. There's a lot just to understand with what like the core protocol roughly is, and intention is that you have a better idea of hopefully how we think about things and maybe how we talk about them with EigenLayer, and kind of run through just like briefly, kind of like an app stack. What is EigenLayer, like AVS ecosystem, EigenDA, and what's next? So real quick, if we're existing in most of the apps that we use on a day-to-day basis, it is using some components of essentially software as a service. In this example, like the Shopify ecosystem, you have a whole lot of competing infrastructure providers that make up the marketplace, essentially, that developers and businesses choose as a part of their stack to be able to build full stack applications that we use on a daily basis. And this doesn't necessarily exist in like crypto quite today. There are things that exist fully on-chain that can be executed as smart contracts, and smart contracts are great for a lot of things, but to build full stack applications, we need more than just a smart contract. We also need maybe RPCs, wallets, services for loyalty or rewards or bridging, and it begins to look something down the line that will roughly resemble this to be able to build out complex applications that can attract users that happen to have crypto running under the hood. So this is a tweet taken from the mainnet launch of EigenLayer and EigenDA. So Ethereum is the verifiable internet, Rollup is the verifiable web server, AVS is the verifiable SaaS, EigenLayer is the verifiable cloud. Those are different mental models that also probably are a big claim, and intention with going through some of the slides is getting some of these aspects of like verifiability roughly understood and understand what it actually means when we mention like verifiable SaaS or thinking about that. But this was 1 year ago, so these have been thoughts that have been around for a little bit. And broadly, when we're talking about verifiability, we're using it within the context of this rough iceberg, essentially. You have like verifiability that's on the top that is delivered to an end user or to whether that's a developer of an AVS or just an end user of an application that happens to use services under the hood. So there's crypto economics, commitments, data availability, decentralization, cryptography, economic security. A lot of jargon that is kind of going on under the hood when we kind of encapsulate it with this concept of verifiability. So different services require different parts of this. And I think that that is like roughly some of the thinking. If you see this term commitment, part of the framing of like commitment as a concept is this idea that if you have, let's say, software as a service, you have maybe an SLA. An SLA in Ethereum is that you're doing essentially the right thing, that you are validating the blocks, you're not double signing, and you have crypto economics that are slapped on top that ensure that there is an incentive to do the right thing, and if something happens that is incorrect, you can get punished. That's roughly a combination of commitments and crypto economics, but you need cryptography, decentralization, economic security, and DA for any of this at the higher level to actually be successful. So talk about this idea of open innovation and kind of thinking about when you're talking about software as a service and that stack, it implies that there's different services that are being provided. If you look at Bitcoin, where the application is that I can send you money if I have your Bitcoin address. And it does all of these things. It's the application, it's the execution, consensus, and security. And Ethereum thought, why should there only be one application? Why can't I build any application on top? I should be able to use the underlying security and instead decide what application or service or protocol on top. And that was a massive breakthrough. Rollups now essentially allow you to horizontally scale Ethereum, where they create a async execution environment outside of Ethereum itself. And now you can have different EVM environments that are running on rollups. And EigenLayer goes a step further, where the idea is that you have this like shared security under the hood provided through like economic security of restakers. And on top of that, services can decide particular consensus mechanisms, peer-to-peer protocols. And what that just enables, really, at the end of the day, hopefully, is useful applications for people. And that's kind of how we roughly think about it. I threw this slide together, and I don't think that this presentation will do it proper justice to maybe even like back up some of the claims. But when we mentioned this idea of like the verifiable commitment cloud or verifiable cloud, some of the ways that we're thinking about this is that underlying infrastructure on an application like an AWS of the world, you don't have to build out your own server. You are not going to hand roll it. It doesn't make sense. So instead, you're going to use some existing server. You're going to use some data service, and you're going to like mix and match services on top using these core primitives that are provided by cloud providers. In a similar way, EigenLayer provides core primitives like EigenDA and eigenforking today to be able to build out services and applications on top. And underlying that, I didn't really mention restaking that much. That is on like the supply side of you need economic security. This is through staked ETH, ERC20s, and there's compute on the operator side. These are the ones that are actually running the services across the world. If you have, using the example of Ethereum, you have a bunch of different validators that have the Ethereum client. The operators in the network are just running the client, it's a Docker image essentially, of the services. So it makes it really easy to bootstrap services in an easy way rather than having to build out all these services and infrastructure yourself. So primitive one being the Eigen token. So there's things that are objectively provable, like cryptographically. As a common example is double signing in Ethereum. You sign twice. That's some of the things that are objectively provable. And then there's a whole other concept of like off-chain provable or intersubjective. I'll like roughly touch on just one, which is for EigenDA, data withholding attack is not objectively provable, or let's say in the example of an oracle, it's not objectively provable, but if you have a reasonable group of external participants in the system, they can check that the price of Bitcoin is not $1 when your oracle claimed it, and they can actually use Eigen token to be able to fork out incorrect behavior and expand what is the scope of verifiability. So the other primitive, EigenDA. So EigenDA, this is what I focus on myself, is a highly scalable DA solution built for Ethereum rollups and other use cases. So 15 megabytes per second might not make sense, but what that is that's like 50x the existing capacity on Ethereum mainnet and 10x any other DA solution. We actually did a stunt earlier this year called All Chains Fit on EigenDA, and that's take all the blocks that have been produced on any blockchain and post them on EigenDA. And that took up 8 megabytes per second essentially of throughput. So the idea is that we scale the effective block space essentially of Ethereum, as well as the effective like verifiable block space for anyone. So a couple like teams that are building on us right now, Mantle, Cello. I wanted a quick shout out as well. There's a lot of conversation around L2s going to L1s. Cello actually did the reverse, and they successfully transitioned from an L1 to an L2 on Ethereum. So some of the teams that are building on top. And with this concept of the Eigen economy, I think that there's a lot of different participants. If you were to walk through the different flows or roles within the system, you have like stakers, you have operators, you have AVS developers, like these businesses that are being built on top, you have end consumers. This is just a general concept that I wanted to throw out there. If you want to get a relative heartbeat on what's going on within the Eigen ecosystem, you can scan this QR code to check out that dashboard there. So this was back before even EigenLayer was like roughly an idea, or not an idea, rather on mainnet. And it was like AVS categories. I think I've mentioned services a couple times, and that's relatively abstract. Like, what are these services? It depends on the user, right? So you might have rollups. As an example, a clear example of that is a bridge. I have 2 rollups, and I need to send money from one to another. I need economic security, and I need to make a commitment that I will bridge from chain A to chain B and do that correctly, and if not, I can get slashed. So there are a variety of different AVS categories. All of these now have at least one, if not multiple teams that are working on it. And just a light site that services and infrastructure is not domain specific. There are services that now have strong guarantees that can be built out in the AI like AVS category on top and be consumed in applications or agents and things like that. So to go into a little bit more depth on EigenDA, mention essentially this like high scale DA, right? So there's some of the features that we focus on is that it's built as an AVS, and that allows us to essentially just do one thing very well, and that's data availability. Essentially, it's a strong guarantee that when you send the data to the network, you can get back that same data whenever, and it's decentralized and secure. So today, running at like 15 megabytes per second, but also other things that, like features that some customers are able to leverage, and I hope can be useful for end users, like fixed cost. So we have this idea of the general cost for, if you're playing for a blob example, for example, if you're interacting with a blockchain, it's oftentimes where the most desirable time to interact with it is also the worst time because of dynamic fee pricing and congestion. This idea is that you can have fixed costs for that, and in fact, roll-ups or users can reserve bandwidth and be able to essentially, like you would on like a cloud service, reserve your usage in advance. And what that means for an end user is that you can have a fixed transaction cost, if it's roughly the execution cost and the data availability cost. If you have one of those variables that's fixed, I hope personally is that this is able to like subsidize the transaction cost for users, as the DA fees are cheap enough for the consumers of EigenDA. I'll like roughly talk on this real quick, is also just like how does EigenDA work? I think that there's different things that are floating around within the DA landscape. So it's built as an AVS, and what that roughly means is that there's a set of smart contracts deployed on Ethereum with economic like stake that has been delegated to operators of the network that are running the EigenDA client off-chain. And how it technically works is this concept of like, we have horizontal scaling. Instead of every node in the network having to store all of the data, EigenDA takes this approach of data sharding, where every node receives just a proportional amount of data. So that allows us to hit this really high scale today, but also allows us to eliminate some of the bottlenecks of general scaling and hopefully hit like 100 megabytes per second over the next year. So like some cryptography, if you're interested as well, you can come talk to me after the fact, but doing some KGG commitments essentially for data integrity of the data, erasure encoding for expanding it, and then prove essentially that the data that I sent you is a part of this batch. And yeah, it's built on Ethereum, so the stakers are between ETH and EigenStake, and the rewards are paid out in ETH. So it's built to scale the Ethereum landscape itself, and it's also economically aligned on that front. So this is more detail. I'll leave it as a after the fact to go into. And just like broadly what's next for EigenDA. So we're continuing to roll out like improvements on the protocol side. So early look is that we'll be releasing our Blazor upgrade. And essentially it's a V2 architecture that allows us to have latency go down to seconds and sets us up for increased throughput. And then also things like DAS, data availability sampling, for like verifiability and handling data withholding attacks using Eigen token forking as the combination and that target there. On the right side, it's a little abstract, but the idea is that if you have infrastructure that is highly expensive and compute intensive, the type of applications that can live on a blockchain or live with the guarantees that we get on a blockchain are gonna have a very high value per bit, AKA DeFi. And those have product market fit on blockchains today because the infrastructure is allowed for that. But if you begin to scale data availability in this underlying infrastructure to the point where it is at like web scale or cloud scale, then you can actually have applications that are creative because you can work with block space that is not necessarily price inhibiting or data inhibiting either. So you can get creative. And then this is like more of a protocol update. Different conversations around slashing. EigenLayer is launching slashing the 17th. What that actually means is that that is like a core part of the protocol, so people can build out their consensus, their verification, and slashing is now something that they can include in their AVS development. And for end users, that means that these AVSs would have to like opt in, like they create their slashing mechanism, create the operator set, and then operators have to opt in. If you want more details of how this combination of like total stake, which is non-slashable, and unique stake, which is slashable. How that works, I would recommend checking out the ELIPs. It's essentially the EigenLayer like improvement proposals. So yeah, that's a big protocol improvement, and like pretty excited to see it launch like securely as well. And yeah, here's our roadmap. We've got a handful of different like categories, but I guess broadly, yeah. So slashing operator sets are two things that go live immediately. But broadly, how we're thinking about it is that you want to decrease the friction for new services to be created. But really, the only reason why services are useful is that hopefully they are built for applications or end users in mind. And enabling end users, bundling different AVS services will be something I think very exciting to enable and answer hopefully some of the questions of like, where are the apps? So if you want, you can check out this after the fact. And then, yeah, thank you for listening to me. If you have any questions, feel free to reach out. If you want, you can join this developer-focused group chat or check me out on Twitter @MattMers. Yeah, thanks for your time.